Hey everyone, it's Presley at ActOutGames.com here, and today we're going to continue talking about basic physics, starting with Newton's laws of motion. So let's start with law number 1. So last time we talked about how you can use free body diagrams to get a basic understanding of the forces acting on an object. This time we're going to use them to get an intuitive grasp on the first part of Newton's first law, which deals with inertia. If you haven't watched the first video or you don't quite understand what a free body diagram is, go watch the first video. There'll be a link in the doobly-doo because you really need to understand what a free body diagram does to be able to do this. So let's start off with something very simple. So I'm going to roll Cooper's toy car across the table, and we're going to talk about what's happening from a force standpoint. So now let's draw a free body diagram of what happens right before my hand leaves the car. So let's start with a box for our car, and our force normal and our force gravity. We know that those are balanced out because the car is not plummeting into the center of the earth or flying off into space. So here's our force normal, our Fn, and our force gravity, or Fg. So now let's do our force applied, which is me pushing the car, or Fa. And now let's just do a tiny bit of force friction, or FF, just because it's slowing the car down, but not enough to stop it. So a teeny tiny bit of F. So now let's do our vector addition to find out what our acceleration is. So let's start with our force normal, 1, 2, up. Our force applied, 1, 2, 3, 4. And now let's do our force gravity, 1, 2, and our tiny bit of force friction, 1. And now let's do our acceleration force, or our net force, and we're going to find out what it is. So from the beginning of the first one to the end of the last one. And just as we expected, it is accelerating to my left because I'm pushing it that way, and it's accelerating that way. But something really cool happens if we draw a free body diagram of the car right when it passes this tape line on the table. Okay, so let's put the car across the tape line again, just so you can see what happens before we do our free body diagram. Okay, so let's start with our free body diagram. So yet again, we draw our box for our car. We'll do it over here. Okay, so we have our box for our car, and now we're going to do our force normal and force gravity again, because yet again, it's not plummeting into the center of the earth or going off into space, so these are going to be balanced. So our Fn, force normal, and our Fg, force gravity. So now let's do our force friction again. So here is our force friction, Ff. And now we actually aren't going to do an applied force because I'm not applying any force by pushing the car, and my hand doesn't have a non-contact force towards the car, even though that would be pretty cool. So we're not going to draw a force applied because the only force I can apply is a contact force, and I am not applying a contact force when it goes across the tape line. So there's no Fa, force applied. So now let's do our vector addition, starting with our force normal, which is 1, 2. And then our force friction, which is just 1. And then our force gravity, which is 1, 2. And now let's do our addition again. And as you can see here, it's actually accelerating to my right because as soon as it leaves my hand, it starts decelerating and slowing down. So that's what we expected. So what's really cool that's happening here is that our car is moving to the left, even though there's no force acting on it and pushing it to the left. And we just take that for granted since it happens around us every day, and we never really stop and think about it. But once you do stop and think about it, it's really, really cool. And it's because of this property of matter called inertia. So Newton did a lot of experiments like this and observations, probably not with toy cars, but he still did some stuff like this. And what he discovered is that if an object is moving, then it takes a force to stop it. So in this case, friction is stopping the car. But he discovered that if there was no force acting on it, stopping it, then it would just keep going forever in that direction until something else stopped it. So that's why rocket ships and satellites in outer space don't always have their engines running, because once they're in space, then there's no air and there's no friction or air pressure acting on them to stop them, so they just keep going and going. So like the New Horizons Pluto mission didn't have to have fuel and engines going constantly, and the New Horizons mission would just go up to speed and then basically just go to sleep and turn off, and then it would keep going because of inertia, and then it would only fire its rockets when it needed to turn and go into a different direction. And that is all because of some simple experiments that Newton did to discover that an object moving, once it doesn't have any forces acting on it, then it will just keep going. So if it wasn't for inertia, if you threw a baseball, then as soon as it left your hand, it would just fall to the ground. Or if you were shooting a bow and an arrow, then the arrow would just fall to the ground as soon as it is being pushed on and being touched by the string. So this has been happening to us, inertia has been happening to us ever since humans have been around, but it wasn't until Newton just sat down and thought about it that we ever really understood what was happening. It's really amazing that just with a toy car, some graph paper, and a pencil, you can recreate some of the thought process that Newton went through when he was uncovering these amazing laws of nature. And you don't need a giant piece of science equipment and all these fancy stuff. You don't need to go to college for years and years to be able to kind of discover and uncover stuff like this. All you need is some graph paper, and I'm basically just a kid in a basement with some graph paper and a toy car. That's all that happened, but I'm still playing with inertia and stuff like that. So it's really, really cool that you can discover stuff like this, and this should also be a huge encouragement, because you don't need to have all these crazy fancy things just to be able to start uncovering some things that happened. So it's really, really cool, and please experiment. Look at the things around you, think about what's going on, and try and figure out why. So our ability just to look at the world around us and think and find out what's happening and better understand our world, it makes me wonder how anyone could think that science isn't cool. So next time we're going to do this kind of same thing to find out why an object at rest stays at rest, just like how we showed an object at motion tends to stay in motion until another force acts on it. So I hope we'll see you there. So if you like our lessons, please subscribe to the channel, it really helps us out. So yeah, thank you for watching, and it's tomorrow.